Hello everyone, it's Benny, and welcome to video 3.5. In this particular video 3.5, we're going to be talking about shaders. They're programs for the GPU which handle very specific tasks on the GPU, like for example the vertex shader, which takes the data that's coming into the GPU and converts it into a form that the GPU can actually do some processing with. There's the fragment shader, which takes pixels generated by the GPU and decides what color they should be. So, stuff like that. And this is one of two video 3.5s. The other one is about mesh creation, which is actually the act of sending data to the GPU. It doesn't matter which one you go through, you're going to have to go through both of them anyways. So, go through either one, doesn't matter which order you go through. This is one option, you can also start with the other one. So if you'd rather start with mesh creation, go ahead over to the other video, I'll wait. Okay, they're gone. And with that, let's start dealing with shaders. So, I'm going to create a new class. This is going to be the shader class. It is going to have a copy constructor and assignment operator, because that's my convention. If they have a destructor, it's virtual and has copy and assignment. And all the other options are exactly as I'd like them. So I'm going to go ahead and create. And yes, I do want to add it to the project. And yes, I do want to add it to my build configurations. And there. So I'm going to delete the implementation of my copy constructor and my assignment operator, just like before. And in my header, I'm going to move the copy constructor and assignment operator to private. And I'm going to change the implementation to just semicolon, remove the semicolon, just put two opening and closing brackets so it doesn't do anything. And I'm going to change this to void because I'm not doing anything. And because it gives me a warning otherwise. So there. This is the basic setup of my shader class. And now I'm going to include a few things. I'm going to include string, because in my constructor I'm going to take in a const std : string reference called file name. We're going to write the actual shader programs in separate files, and then here in this class we're just going to load them in and then build them for the GPU. I know we're actually going to be doing some compilation here. And then we're going to send the built files to the GPU. That's how this is going to work. And there. And as for the actual shader functions, we're just going to have one. It's going to be called bind. What this method is going to do is it's going to, well, I want to say bind the shader, but specifically what it's going to do is it's just going to set the GPU in a state so that it's using the vertex shader and the fragment shader that are part of this particular shader class. That's what the bind function is going to do. So if I have if it's already using some other vertex shader function, or some other fragment shader function, or if it's not using any vertex or fragment shader functions, it's just going to say, okay, stop using those and start using the shader programs provided by this particular shader class. And there. So now another thing I want to include, if I can spell, I want to include gl/glue.h because I'm going to have a GL unsigned integer called m_program. This is OpenGL's way of keeping track of where the program is. It's a handle, and it keeps track of the handle in GLUNs. So there you go. And that's how we're going to refer to our shader program with OpenGL, with this unsigned int. And finally, we're going to have an array of GLU unsigned ints called m_shaders. And it'll be of size num shaders, and that's going to be a static const unsigned int num shaders. Just set it to, I'll set it to 2. And the reason we're doing this rather than just having a GLU int for fragment shader and GLU int for vertex shader is because those aren't actually the only types of shaders you can create. There's actually this other type called the geometry shader, which works on triangles and lets you do stuff with that, but we're not really going to handle that in this series. We're just going to talk about basic vertex and fragment shaders. So I'm going to set this to 2. If you're going to deal with geometry shaders, you might want to set this to 3. I'm just dealing with it like this. I'm dealing with it like this. And, yeah, I'll leave it like this. If you really wanted to, you can create an enumeration which says which one refers to which, but I don't think it's particularly important in this case, but you can do that if you want to. So anyways, let's go to our constructor get rid of the comments. Well, our constructor and destructor, and get rid of the comments. And if I can select, there, tab over, and let's go ahead and get started. Oh, and first, let's change this to a const std string reference file name, so it matches the parameters of our, well, of our header file. And now let's get started. Okay, so you may have noticed that a whole bunch of code has just appeared out of nowhere. Don't panic, sit back for a moment, and let me explain. Since we are loading a file off the hard drive and then doing a whole bunch of processing, we're compiling it and linking it like it's a program, and then sending it to the GPU, there's a few things that are necessary, but they really don't have that much to do with shader creation. They don't have that much to do with what we're doing. So I've gone ahead and provided two helper methods for those. The first one is load shader. It looks a little something like this if you really want to write it out by hand, otherwise it's on GitHub. And all this is going to do is it's going to load a text file from the hard drive. You've probably seen this code a million times before if you've done any I/O with C++, or code similar anyways. And yeah, that's all this is. It loads a file off the hard drive. And this one, it checks shader error. Since we are doing compiling and linking, there's always a possibility of errors. So, you know how when you build your C++ program, and sometimes there's this big, gigantic list of error messages, and you're wondering where they all come from? That's this method. It's finding those error messages and generating them and giving them to us. Except for shaders. And this is what it looks like. Again, this one's also on GitHub. And again, the reason I'm not going to be going over these and coding them out by hand is because they're necessary, but they don't have that much to do with shaders, and I'd rather keep this focused on, well, shaders. So that's what they're for. I think I gave them enough screen time if you really want to write them out by hand. Otherwise, you can get them off of GitHub and just copy and paste. So with that, let's go back and actually get back on track and start writing out our shader using our new helper methods. So, first thing I want to do is I want to take our m_program, which is our shader program, and I want to create it. I want to tell OpenGL, hey, we're creating a new shader program. The way we do this, gl create program does exactly what you think it does. It'll create a new program for us, some space on the GPU for our program, and OpenGL will give us, well, some number to refer to it by, and that's what's going to be stored in mprogram. And our destructor, I'm going to say gl delete program, and I'm going to pass in mprogram. Because, you know, once we're done with it, we don't want the program sticking around on the GPU forever, so that'll tell OpenGL, hey, we want to delete the program. Pretty simple, nothing too mind-blowing just yet. And now, what I'm going to do is I'm going to start creating these things, our shaders. Well, yeah, like the individual shaders, like the vertex shader and the fragment shader. So, for shaders sub 0, I'm going to say that's the vertex shader, and this is the only time we're actually going to refer to it as shaders sub 0. That's why I'm not really going out of my way to make this into an enumeration, so that we can always refer to it by that. And in order to actually create a shader, that's also requires a little bit of processing, and it's pretty similar no matter what shader you're going for. So I'm going to create another helper method for that, and we're going to write this one out by hand because it is directly related to shader creation. And it's going to be static gl uint, because that's what shaders are. At least that's how OpenGL refers to them, with unsigned integers. GL unsigned integers, that is. And I'm going to call it create shader. Takes in some const std string reference that I'm going to call text, the full text of the shader program. And it's also going to take in another gl uint. Or actually, is it gl enum? I think it's gl enum, actually. Maybe I'm wrong. If we're going to find out, but I think it's actually gl enum. I think I had that wrong, so sorry. A gl enum that I'll call shader type. Sorry if I cut off in the middle of typing this. I had a little bit of a cough, but yeah, this is what it looks like. And this is our helper method. So I'm going to go ahead right below our destructor and just put an empty implementation for it for now. We're going to implement this in a moment, but I want to finish off our constructor first. So what I'm going to do here is I'm just going to say my shaders sub-0, that's going to be create shader. I'm going to create a shader. And it's going to take in the full text of the shader. And in order to get that, I'm going to use my helper method, loadShader, to load the shader from the file, or from our file name. So of course I'm going to pass in file name. And that should give us the text of the shader. As for the shader type, I'm going to say 0 is our vertex underscore shader. And so yeah, this way we'll know. This way we know in our helper method what type of shader we should be creating. And I'm going to do the same thing for number 1, except this time for GL fragment shader. And in order to distinguish which file has the vertex shader and which file has the fragment shader, because they're going to be in 2 separate files, I'm going to use slightly different file extensions. I'm going to say the vertex shader has an extension .vs. I'm going to add it when I'm loading the shader like this, with plus.vs, just add as a string constant. And same for the fragment shader, plus.fs for fragment shader. And these file extensions are just my personal convention. There's really no standard as to what should be the file extension for various vertex and fragment shaders. So you can use whatever extension you want, or whatever method for distinguishing them you want if you don't want to use file extensions. I've always used this way of distinguishing them. And yeah. So there. Now we've got our program, at least we've got space for it. We have our shaders, and I'm going to say create shader did everything for us. It built them, it did everything. They're fully ready to be used. So we got our shaders, which are not only allocated, but are fully ready to be used. Now what? Now we want to add our shaders to our overarching shader program. And the way you can do this is OpenGL provides a nice method for that, but since I want to do it for every shader, I'm going to do this in a for loop. So for unsigned int I is 0. I is less than the total number of shaders, because I want to do this for every shader, and then I++. And for every one of these, I'm going to have a method, or OpenGL has a method, GL attach shader. This will take some program, such as mprogram, and add a shader to it, such as mshaders of I, whatever the shader is for the iteration we're on. And that'll add all our shaders to the shader program. And there. So now that we have all the shaders attached, what now? Well, the shaders at this point should already be built, so all we really need to do is 2 things. 1, we need to link them, so, linking like in compilation, where all the compiled code gets linked together into the big final program. And then validation. We want to validate that we ended up with an actual valid shader at the end of this process. So for linking, OpenGL has a method for that called linkProgram. That takes in some programs such as mprogram. And this can fail if something goes wrong, if they aren't linked properly. So here what I'm going to do is I'm going to use our checkShaderError method. And I'm copying the name just because I'm lazy. The shader we want to check the error for is mprogram. Well, now we can specify what flag we want to look for, and I want to look for GL underscore link status. And now we have a little boolean here telling this method if we're checking for error in an overarching shader program or in one of the individual shaders. We are in the program, so I'm going to pass in true. And finally, the error message. So I'm just going to say error shader program. I'll say just program, actually, be concise. Program failed to link with, how about this? Program linking failed. There. And then it'll add on to this whatever the error message from OpenGL is. And there. And we want to do one more thing that's almost just like this. Not quite, but almost. And except rather than linking, we're going to say GL validate program. This will just make sure that even after linking, even if linking succeeded, that still the entire program is still valid. Nothing has gone horribly, horribly wrong here. We still have a valid shader program that we can actually, use and get something meaningful. And I'll do this with GL validate status. That's the only thing I'm going to change here because we're checking whether the shader validated properly, not whether it linked properly. And I'll say here, program is invalid. And I actually forgot something. And this is actually a really bad thing to forget, because it's one of those things where it won't obviously fail if you don't do it. But if you don't do it, you're going to run into some really nasty bugs later down the road. And that is GL bind attrib location. You're going to want to do this before you link and validate the program. What this does is it tells OpenGL what part of the data to read in as what variable in your shader program. And I'll talk more about what exactly this does. Oh, it takes in the program. And I'll talk more about what exactly this does once I have both the mesh and the shader created, because hard to talk about that with just the shader created. But here you go. So you're going to bind it. I want to bind attrib 0 to the variable, position. Make sure they're spelled the same, or make sure this is spelled the same as in the vertex shader program. The vertex shader, once we actually write that, you'll know when you see it, or you'll run into some issues. So yeah, just make sure you have that in there. I forgot. And there. And once we validated that this is indeed a proper program, we should have a shader that's pretty much ready to use. And since I do want to hold off on shader creation, I'm going to go ahead and implement bind, because bind's a really easy method to implement. So I'll say void bind, and put a tab here, and this is going to be shader : bind, and this is done really easily with GL bind shader, or bind program, excuse me. Huh. That's strange. Don't know why it's ARB. In fact, I'm going to hold off on that because that doesn't seem right to me. And I'm going to check to make sure I really am binding the program correctly. So one moment. And I'm glad I checked, because that's not what the function is called. I apologize. It's called GL use program. And that's where you pass in program. Yeah, sorry, I don't have every single OpenGL function memorized. But there you go. And also, I completely forgot to include IOStream and to include FStream. So FStream is file stream, that's for loading files, like in load shader. And IOStream, of course, is just displaying text. And I need that because that's what getShaderError uses. And also load shader uses it too, but mostly for getShaderError. And yeah, so sorry, just forgot to include that. And one last thing before we actually implement createShader, and that is deleting the shaders. Because, well, deleting the program doesn't actually delete the individual shaders. So I'm going to have another for loop, kind of like this one. In fact, I'm just going to copy and paste it, and expand it out. And first off, I'm going to say GL detach shader. I'm going to say improgram, shaders sub I. So that'll say that mean that the shader will no longer be part of the program. And then GL delete shader, _shaders sub I. And that will actually delete the shader. We haven't actually created it yet in our code, but when we do, that'll actually delete it. So yeah. And that completes our destructor. It goes through, removes every single shader from the program, deletes every single shader that it removed, then deletes the program, which is exactly what we're looking for. So now, finally, let's create the shader. I'm going to have a GL unsigned int, call it shader. Now say GL create shader. And eventually I'm going to end up returning the shader. And on the most basic level, that's what this function does. But first, well, I said before I actually end up returning it, I want to, well, actually do something useful with it. I want to take the shader text and build it and compile it and put it into this shader. So first off, I'm going to do an error check. If shader equals 0. Because if it does equal 0, then OpenGL hasn't actually given us a shader. It's run out of memory or something or other. So I'll just say stdcerr, error shader creation failed. And std end l. There. So just an error check. It probably won't happen, but, you know, it might. And it's better to have the message there in case it happens rather than wondering why the error is going wrong on the off chance that it does. So, yeah, at least that's my philosophy. So now that we know that the shader is valid, let's compile it. Let's take our text and let's build it. However, OpenGL is a C API, so we're going to have to take our std string and convert it into, well, C strings. So I have a const GL char pointer, so it's the proper, well, size per character, as OpenGL expects. So not just a regular GL char pointer. And I've always called this... You know, I really have never had a good name to call this, because it's actually going to be a list of strings. Because you can have more than one string for the shader text if you really want to. I don't, but it's an option OpenGL provides. So I'm just going to call this P0, just because that's what I've always called it. I still don't have a good name for this. Okay, how about this? Shader source strings. There. Much better. And it's going to be, whoops, an array of size 1. And I'm going to set shader source strings of 0 to text.cstring. So there, now I have, well, the appropriate text. But of course, C doesn't store the length of the string, and OpenGL is going to want to know about that, so I'm going to need GL int, call shader source string lengths. Also going to be a size 1. And yeah, I'll just space it out here. Source string lengths, I'm going to set of 0. I'm going to set to text.length. And there, that should convert our regular string to a list of one C string and its length. So that's all done. And with that, we now have everything we need to actually get OpenGL to compile our shader. It's not that hard, it just takes a bit of code. So the way we send our source code to OpenGL so it can do its thing is with GL shader source. And the reason I say do its thing is because the way this method's implemented depends on your graphics driver and graphics card, so there. And if I remember correctly, this takes in shader. It takes in the number of different source strings, which is 1. And then it takes in the actual list, which will be shader source strings, and the list of lengths. So shader source string lengths. And I'll check off screen to make sure I got those parameters correct. I'm pretty sure I got them correct, but I'll check just to make sure. And then after we've sent it the source code, we can tell it, okay, now you got the source code, go ahead and compile it. So go ahead, compile the shader. And at that point, we've got the shader built, but maybe we have some compile error, maybe there's a typo or something. And this is where we're going to want to once again use GL check shader error. And I'm going to copy from here because I'm lazy. Here we're going to pass in the shader, that's what we want to check the error for. Here I want to check for GL compile status. Now this is not an overarching shader program, it's just an individual shader, so I'm going to pass in false here. And I'm going to say error shader compilation failed. There. And then it'll give me the error message that OpenGL gives. And after that, it should return the shader. All the rest of the initialization should go through as planned. And with that, folks, I believe we have everything we need to actually use a shader. So now all we have to do is write the shader that we're going to build with this class and actually use it. So to actually use this, it's pretty simple. First off, of course, I want to include it, so include shader.h. And since we've given our shader system a pretty simple interface, it's not going to be that hard to use. So I'm going to have a shader called shader, and it's going to take in the path ./res/basic shader, because that's what I'm going to call the shader file. And in here, I'm just going to say shader.bind, so that we'll be using the shader whenever we actually end up drawing something. Again, this is just focused on shaders, and we don't have anything to draw yet, but it'll be in use when we do. Now we have to actually create this basic shader, though, and that's a little bit deserving of its own topic, so I'm going to create first off the res folder, and I'm going to create the document. So basic shader, and I'm going to say .vs for the vertex shader. I'm also going to create another new document for basic shader.fs. Going to go ahead and create them. And the actual language that OpenGL uses to write shaders and how you use it definitely deserves its own topic. Because I'm not making a video on that yet, because this video is focused on shaders, and because it's really not going to make that much sense anyway, since we don't have the actual data component, I'm just going to write out some valid code, and you can copy it for now. And once we have everything together, then I'm going to actually start talking about what this code means and how we can do some pretty seriously amazing stuff with this. So first off, OpenGL wants us to specify a version. This is very C-like, so it's going to be hashtag for preprocessor directive, version 120 for version 1.2. And that goes for fragment shader too. We want to tell OpenGL what version we're using. You can use later versions. I'm just going to use 120 for this tutorial because I'm not doing anything that explicitly requires a newer version. So, there. Now, all the actual code is in a main function, just like in C. And we can specify what we want to take in from the data with the attribute keyword. I'm going to take in an attribute called position. And it's going to be of data type vec3, which is a vector 3. And again, I'll talk more about this when it becomes meaningful. And my actual code is just going to set GL position, which is the actual position that the GPU is expecting, to the position we passed in. But I'm going to convert it to a vector 4 because it expects... Whoops. Make sure you spell position right. Convert it to vec4, which takes in position and 1.0, because it actually takes in a vector 4 position. I'll talk about why it takes in a vector 4 rather than a vector 3 later. Again, but this is a valid OpenGL program, just takes in position as data and just does... This is pretty much the identity program, I guess you could say. It just takes in the position, spits back out the position exactly as it was taken in. So yeah, and that's how it looks. This is what code looks like. I'm going to move on to fragment shader. So, this is just takes in a main function. I'm not going to take in any data here. Taking in the pixel sort of implicit. And for GL frag color, which is the output location, this is the output pixel, I'm going to set that to a vector 4, which is going to be pretty much RGB and alpha, where 1 is maximum RGB or alpha and 0 is minimum. I'm just going to say 1.0, 1.0, 1.0, 1.0. So this should just output... You know what, let's make it more interesting. I'll say 0 for green and 0 for blue. So this should say every pixel ends up being red. And that's our vertex and fragment shader. If everything worked, so I'm going to go back here, I'm going to build. Okay. Num shaders, make sure that's spelled correctly. And this should work. And again, I'll talk more about this when it's appropriate, but yeah. So if GL create shader, because it takes in the shader type. So there, I completely forgot about that, sorry. And string lengths, I've apparently spelled wrong, so let's copy and paste. There we go. What did I spell? Source string lengths? Yeah. Shader source string lengths. And there, so now it should build. Now if I run, it didn't give us an error. We don't see anything new because we're not drawing anything, but at least our program built correctly. Again, I'll talk more about what the program actually means and how you can do stuff with it in a later video when all this stuff is more meaningful. But for now, this should give us a basic shader that draws red triangles when we provide the appropriate data. So thank you, hope you enjoyed, hope you learned, and I'll see you in the other video 3.5 where we actually create the mesh data that we can draw with the shader, or I'll see you in the next video where we'll start... Well, I'll leave that as a surprise for the next video. Thank you, see you then.